3 parts on this one. All right, so
3 parts?
yes,
Oh, man.
an inscribed angle and other angle relationships in a circle. Okay. So yesterday we talked about one type of angle. What was it called? A central angle. Today we're going to go a little bit more into the other types of angles that there could be with circles. We'll start with an inscribed angle. An inscribed angle is an angle whose vertex is on the circle and the sides are basically points. Okay? Now, a central angle, where was its vertex located? At the center. And the sides of the angle were radii. For an inscribed angle, the vertex is actually on the circle and the sides are chords. So does everybody see that? Here, you see the difference between an inscribed angle and a central angle? Okay. Now, the arc that lies in the interior of the inscribed angle, meaning the arc that's in between the two sides, does everybody see that?
Yes.
It is called an intercepted arc. All right? So, an inscribed angle, the arc that's in between the angle is called an intercepted arc. So as you see, angle ABC is an inscribed angle, and arc AB is its intercepted arc. Okay.
Does that mean it forms a triangle?
No, more like a sector. Okay, because this is a curved part versus a straight line. Okay.
So would angle ACB be 60?
We're actually going to get into that. You guys have it on your paperwork, but it's going to be on my next slide here. The measure of an inscribed angle is actually half the measure of the arc. Okay? So, if I were to go back, I know this central angle is 60, which means the arc is going to be what? 60. And so the inscribed angle is going to be half of that arc, which is 30. Okay? So the measure of angle ACB is 30. Now if I had another inscribed angle, and say that my inscribed angle was 45 degrees, I can use a little bit of inductive reasoning to figure out that my arc is how long? 90. Because you double it. Does everybody understand that?
Just like the other one.
I just don't understand you got 30.
Wait on, Christian.
On the other lesson, you double the outside arc on it?
No, it was the exact same, because those were all central angles. Here, because we have an inscribed angle, we're either gonna double the angle to get the arc, or take half the arc to get the angle. Well,
How did you get 30 from, like if you started off with just 60 as the central angle and then you, how did you figure out that 30 was?
okay, well we know that the central angle was 60, and you see the arc,
Oh, never mind.
And
I
so-
see it, yeah. It's
yeah,
okay.
they had the same arc, okay? Other questions?
You realize they had the same arc.
Is there gonna be a test on this?
Yes. Okay? But realize it's the first time you're seeing it. So the more you see it, the more you can practice with it. Trust me, you'll get your practice. It'll be easier for you. Okay? So, again, the inscribed angle is half the measure of this intercepted arc. Now, if two angles of a circle intercept the same arc, then their angles are congruent. If you have two angles, you guys see the angle that's in black?
Yes.
You see the angle that's in red?
Wow.
Don't they have the same arc?
Yeah.
Okay. What's the arc?
They did until you
AB.
drew one.
AB. If they have the same arc, then that means the angles are congruent. Okay? So if this arc was 50, then I know that angle ACB is how big?
25.
25.
Oh, dang.
Uh-huh.
What are you doing, Casey?
And angle ADB is what?
600.
Was angle ADB?
25.
25.
25. What kind of angles are these, you guys?
There.
True, but what is their name?
It's the word that you
Exterior.
said, the.
Inscribed. Everybody say inscribed.
Inscribed.
And the difference between an inscribed angle and a central angle is the vertex. Inscribed, the vertex is where? On the circle.
Yes.
Central,
In
inside, and more specifically,
center.
at the center. Okay? So we're gonna look at some examples. Now, this may look confusing, it's just 5 examples that are pushed into one page, okay? So that's all it is. So we're just gonna go ahead and split this up. Let's look at number 1. It says that AC is a diameter. Let's think about this. The diameter is what to the circle? Cut it in half. So I already know that arc ADC is how big?
Got it.
180. Okay? So this arc is 180. And it asks us to figure that out, so that's 180. So the measure of angle ABD
Yeah.
is going to be 90. Because it's half of this intersected arc. Does everybody see the arc? You see how the angle, like the endpoints are basically the arc, the endpoints of the arc? Okay? I mean, that's why I'm trying to show it in color so you can see, okay, from one angle, from one endpoint to the other, that's the intercepted arc. Okay? Let's look at number 2. Number 2 says find the measure of arc ADC. Well, here's arc ADC. I know angle ABC is 80. So I times it by 2. Very good. And so, what's the measure of the arc? 160. Okay, Ryan, pen. Saul, pen. Sit up straight. Okay? Is everyone following? I'm going slow for a reason.
Sorry, I'm slow. I'm slow learner, guys.
Hmm?
Can we rewind? I'm not catching it.
Okay.
Casey's actually serious.
Alright. The trick is, okay, first off, the intercepted arc. Does everybody understand what I'm saying by intercepted arc?
Yes.
It is the arc that's in between the endpoints of the angle. Okay?
Oh, so
That's why I keep that's why I'm coloring over it so you can see where the arc is.
But isn't that just like every arc?
No, there's certain arcs. And see, if you look at this angle right here. The endpoints of the angle, the arc in between is the intercepted arc.
The endpoints. Oh, okay. Instead of being like where it's just the endpoints of a chord, the endpoints of an angle that's opposite from it. Okay, I get it.
Okay? And so then the measure of the angle is going to be half of the arc that goes in between the two.
Okay.
Okay? So, let's look here. I have to find the measure of angle ABC. Well, I know that this arc right here is 198. Okay? So how'd you get 99? Because you take 198 and you divide it by 2, which is 99. So the measure of angle ABC is 99. So I take half of the arc.
No, because there's like 5 angles.
Okay, that's fine. It's totally fine.
They all connect to the same.
This type of stuff you do to
No,
us.
no, no.
You give us these smaller ones during class and the homework.
You look at all three.
No, see, y'all just overthink the whole.
Like the 80, they all
Say what?
They have all the same arc.
What's the arc that they all have in common?
90.
The 90-degree arc from A to E.
They all come together as 80.8.
Look at it. Angle A, B,
Oh my God.
E.
It's not that hard, is it?
It's 45 degrees.
See, look, I would.
I know, because you look at it, you're like, oh my God, I can't do it. Like, you know,
That's what I thought.
you just gotta try it, okay? A, C, E. Let's measure. 45, it has the same arc. And the last one, ADE,
90.
45. So that theorem where it says that if they have the same intercepted arc, all the angles are congruent. Okay? That's an example in that case.
fifth grade or somebody walked in and they started crying when they looked
Not
at
colors, they're like, ooh, colors.
the board. They started crying.
So it says angle B, so this angle right here is 44 degrees. Now, this angle B, is it a central angle or is it an inscribed angle? Inscribed. So I know, if I know the inscribed angle, I can figure out its intercepted arc. How big is that? 88. Because all you do is double the angle. Now the question asks me to find the measure of angle C. Well, here's angle C. The angle is going to be what?
44.
And how do you know that?
They have the same arc.
They have the same intercepted arc. Okay? So remember, if they give you the arc, you divide by 2 to get the angle. If they give you the angle, you double it to get the arc. So let's practice this. I want you guys to go to the exercises in the back, and I want you to look at 13 through 18. Okay? I want you guys to try 13, 14, and 15 just right now. Do 13, 14, and 15 just right now. If I look at number 13, that 87, is that
The angle.
which angle? What's it called?
Central.
A central angle. And you know central angles and their arcs are congruent. So the arc is 87. Now it's asking me to find the measure of angle BAC. And BAC is what type of angle?
Inscribed.
Inscribed. So to find it, you just have to divide by 2. And what's 87 divided by 2?
Wait, what?
Okay. Did you understand when we found the arc was 87? Okay?
Wait, I thought the arc should be one, I thought the arc should be 2 times that.
But see, we're given the central angle, which is
Yeah.
87. And central angles and their arcs are congruent.
Oh,
That's how we're able
it's
to
a
get
central
87.
angle. I thought, but how do you know?
How do you know? Because of, look at where the vertex is. If it's in the center, it's a central angle. Circle O represents your center. That's how you'll know what's the center or not. Okay, over here. The 28 degrees represents this angle. What kind of angle is it? Inscribed. And I'm looking for the measure of the arc. So how big is the arc? 56, because all you do is double, multiply by 2.
The one side is open.
Okay? I gotta walk. You can walk off.
I didn't.
Okay, over here. This 142 represents an angle. What angle is 142? The central angle of DOC. So if this angle is 142, I also know what?
It's the diameter, so that BC is whatever, is 38.
It's gonna be 38, because DB is a diameter. And diameter cuts the circle in half. So 180 minus 142 gives me 38. So then I know the arc BC is 38. So that means the measure of angle BAC is 19 because it's half of 38. Questions? It's the time to ask. I'm telling you, I don't want to keep going forward if we're not understanding.
How much harder is it gonna get?
Okay, with just regular inscribed angles, the next ones you see, that's probably gonna be the hardest that it gets because it has clearly, it's gonna be equations that you gotta set up. But it's the other types of angles that can be kind of tricky.
Alright, no, this is
Okay.
number 11.
Oh, God.
Here we go.
16 to 2, 5x plus 4 equals 208 divided by 2.
Okay,
That's what I do.
that is a good thing to do, okay? This right here is an inscribed angle.
That's what I would do.
And the inscribed angle is half of its intercepted arc. So 5x plus 4 equals half the arc. Okay? That's what we've been talking about. Now we just have an equation here, and we're looking for x.
82.
XC. Oh.
So I have 5x plus 4 equals 104. What do I do?
Subtract 4.
Subtract 4, so 5x equals 100, and x equals 20. Okay? So this is probably like the hardest that it's going to get because it's asking you to find the value of a variable versus just, okay, what's the angle? Alright? Yes, it's not that hard, you just gotta remember which angle is which. Okay? Over here, I'm given this angle, and I'm also given this angle. Now, both of those angles, the purple one and the orange one, are both what kind of angles?
Inscribed.
Inscribed. And if you notice, their intercepted arc is the same.
2x plus 11.
So they're congruent. Because they share the same intercepted arc, that means the angles are congruent. So you set them equal to each other.
Yeah, no, number 18.
Okay, wait, hold on, we get there, we'll get there.
Each other.
Okay? So, you'll have 11 equals 2x minus 3. 14 equals 2x. So x is what? 7. Now you can always check your answers by plugging in and making sure that the angles are indeed congruent. And over here, making sure that this angle is half of 208. Now, number 18. It's not hard. You just see fractions and you just automatically think it's hard.
Yes.
It's not. This angle right here is a central angle, which means that the arc is also the same. 1/2 plus 1/2 x plus 12. So that's the measure of the arc. Now this angle up here, what kind of angle is it? Inscribed. And we know that the inscribed angle equals what?
Half of the.
Half?
Half of the arc.
Half of the arc.
So you do like 1/4 of the 1/4 x plus x.
I'm out of space here, okay? So 1/3 x plus 3. The inscribed angle is half its arc, its intercepted arc. Now you see fractions and you panic for whatever reason, I don't know. What are you gonna do to that 1/2?
-1. Well,
I thought you were
actually,
doing
no,
4.
no.
You can either divide it by 2
Distribute.
Huh?
Distribute.
No, it doesn't cancel out.
Distribute.
I can distribute, okay?
Cancel
So
out.
I have a 1/3 x plus 3 equals, what's 1/2 times 1/2? 1/4. Because I'm multiplying here. What's half of 12? 6. Now, if you are so concerned about fractions, get rid of them, okay? It is very simple to get rid of them. What number does 3 and 4 both go into?
6.
What?
Did you say 2 and 4?
No, 3 and 4.
4 doesn't go into
Okay, so if you don't like fractions, get rid of them. Because I will tell you this, 1/3 is 1.3333 repeating, okay? And if you round that, your answer is going to be off. So go ahead and just multiply every single number by 12. Yes, because that was the number that 3 and 4 both went into, right? The denominators? Okay, so if I multiply every single term by 12, what is 12 times 1/3? So this becomes a 4x. What is 12 times 3?
36.
What is 12 times 1/4? So that becomes a 3x. And what's 12 times 12?
12.
No more fractions, right?
That's a lot.
And
So what do I do?
Subtract 3x, add 36, x equals 180. Right?
wait, isn't this supposed to be 1x plus
Yeah,
6?
it's 180.
There.
That's what I was
Oh,
saying.
okay. My mistake. I was trying to copy it over. I didn't remember. What is 12 times 6?
Ah.
36.
Try again.
Oh.
72. And this, both of these were pluses?
108,
Were both of them pluses?
Yeah.
Okay. So then all you gotta do to solve for x is what?
add 36, or stack 13.
Subtract 36. So x equals what? Okay? So again, if you do not like fractions, get rid of them. You just can't ignore them. You actually just multiply by the lowest common denominator. That is
See, what if we
seventh
get
grade.
What if we get like a messed up fraction, like 1/5 and 12?
So then what number does 5 and 12 both go into? 60. 30?
No. What is that?